In this episode, we take a big step toward writing automation that stays understandable as it grows, because growth is what breaks most scripts. At first, a script feels manageable because everything is in one place, and you can scroll and see the whole story. Then you add more checks, more edge cases, more environments, and suddenly the script becomes a long, tangled chain where one small change can create an unexpected side effect somewhere else. Functions are one of the best tools for preventing that outcome because they let you package a piece of logic into a named unit with clear inputs and outputs. That packaging is not just for neatness, because in operations, neatness is a form of safety. When logic is encapsulated, you reduce the risk that one part of the script accidentally interferes with another part, and you make it easier to validate behavior and troubleshoot failures. The goal here is to understand functions as a reliability pattern, where you create small blocks of code that do one job, do it predictably, and communicate clearly with the rest of the script. When you learn to think this way, both your code and your exam answers become more stable because you can reason about behavior in chunks instead of in one giant mental tangle. Before we continue, a quick note. This audio course is a companion to our course companion books. The first book is about the exam and provides detailed information on how to pass it best. The second book is a Kindle-only ebook that contains 1,000 flashcards that can be used on your mobile device or Kindle. Check them both out at cyber.author.me in the Bare Metal Study Guide series. A function is essentially a promise. If you give it certain inputs, it will perform a defined operation and produce a defined output, or it will fail in a defined way. That promise matters because it reduces guessing, and guessing is what causes operational risk when you are running automation under pressure. Beginners sometimes see functions as an advanced topic, but the core idea is simple. You name a behavior and you reuse it, so you do not repeat the same logic in 5 different places. Repetition is dangerous because each copy can drift, meaning one copy gets updated and the others do not, and then the script behaves inconsistently depending on which path is taken. Functions prevent drift by creating one authoritative version of a behavior, which makes maintenance safer. Functions also make code easier to read, because a well-named function tells you what a block of logic is trying to accomplish without forcing you to inspect every line. Reading is an operational skill because troubleshooting often happens when you are tired and the incident clock is ticking. Clear functions reduce the cognitive load of that moment. Encapsulation also helps you manage scope because variables inside a function can be local, meaning they exist only where they are needed and cannot accidentally leak into unrelated logic. This is a powerful safety feature, especially in larger scripts, because it prevents name collisions where the same variable name is reused with different meaning. Local variables also reduce the chance that some other part of the script changes a value you were relying on, which is a common cause of confusing bugs. When a function has a small set of inputs and produces a clear output, you can test it mentally, because you can ask, if I call this with these values, what should I get back? That mental testing is exactly what the exam often asks you to do in concept form, like predicting outcomes or identifying where a bug would occur. Encapsulation makes that reasoning easier because it creates boundaries. Boundaries are what keep complexity from spreading. A practical way to design clear functions is to make each function responsible for one thing, and to give it a name that describes that responsibility. In operations, you often see responsibilities like validating input, parsing data, transforming a value into a standard format, deciding whether an action is safe, or performing a single repeatable step. If a function tries to do multiple unrelated things, it becomes harder to understand and harder to reuse, because its behavior becomes a mixture of concerns. Mixed concerns also make failures harder to interpret because you do not know which part failed without diving into internal details. A function that does one job can be used in more places, and it can be replaced or improved without rewriting the entire script. This is a key risk reduction strategy because it limits the impact of changes. When you hear people talk about maintainability, this is what they mean in practical terms. Small changes stay small. The exam may not use that word, but it often tests the outcome, which is choosing designs that prevent change from causing unexpected failures. Functions also create a natural place to handle errors consistently, which is essential for automation that needs to fail safe. If validation logic is scattered everywhere, different parts of the script may react differently to the same problem, which makes behavior unpredictable. If the validation logic is encapsulated in one function, you can ensure that invalid input is detected the same way every time and that the failure behavior is deliberate. Consistent error handling also improves visibility because you can design the function to return a clear result, such as a success indicator and a reason for failure, rather than leaving the rest of the script to guess. Even at a high level, the principle is that functions should either return useful results or signal clear failure, not silently do nothing or silently produce partial output. Silent behavior is risky because it looks like success. Operators do not fear failure as much as they fear uncertainty, because uncertainty makes decision-making slow and error-prone. Clear functions reduce uncertainty by making outcomes explicit. Input and output design is where beginners can accidentally create confusing functions, so it helps to think about what makes an interface clean. A clean interface uses the smallest number of inputs needed to do the job and returns a result that is easy for the caller to use. If a function needs 10 inputs, that might be a sign it is doing too much or that the surrounding design is not grouping related values well. If a function returns something vague, like a string that sometimes contains data and sometimes contains an error message, it becomes hard to handle correctly and can lead to bugs where errors are mistaken for valid output. A safer approach is to return predictable types and predictable structures, so the caller can make clear decisions. This connects directly to data types, because consistent types prevent accidental comparisons and misinterpretations. It also connects to fail-safe conditionals, because the caller will often use the function's output in a conditional to decide what to do next. A good function makes that conditional straightforward. Functions also support reuse across environments and teams, because they allow you to standardize how certain tasks are performed. For example, if multiple scripts need to parse a common format, a shared parsing function reduces the chance that one script parses differently and produces inconsistent results. If multiple scripts need to validate environment names or normalize paths, a shared function ensures those rules are applied consistently. Consistency is a major reducer of operational risk because inconsistent behavior is hard to predict and hard to troubleshoot. Shared functions also encourage shared vocabulary because when teams use the same function names, they develop a common language for what the automation is doing. That common language is valuable in incidents because it lets people communicate quickly about what might have failed. Even if you are learning alone, building this habit makes your automation more professional and easier to scale. Exams tend to reward this thinking because it reflects how real automation systems are kept stable. A frequent beginner mistake is to write functions that depend heavily on hidden external state, such as global variables or environment conditions that are not passed in as inputs. When a function depends on hidden state, it becomes harder to reuse and harder to test, because you cannot call it with explicit values and get predictable outcomes. Hidden state also increases risk because the function's behavior can change based on things you did not realize were relevant, like a variable set earlier in the script or a setting in the environment. A safer design is to pass in what the function needs and to have it return what the rest of the script needs, keeping the dependency chain visible. This does not mean you can never use shared state, but it means you should be cautious and deliberate, because shared state is where surprises hide. When the exam offers an option that reduces hidden dependencies and increases explicit inputs and outputs, that option is often the more reliable design. Reliability is built on visibility of assumptions. Functions are one of the best ways to make assumptions visible. Another risk-reducing benefit of functions is that they encourage you to think in terms of testable behavior. If you can describe a function's purpose in one sentence, you can often imagine a few example inputs and what the outputs should be. That kind of mental testing catches logic gaps early, such as forgetting to handle empty input or forgetting to handle unexpected formats. It also encourages you to define what failure looks like, which is critical for safe automation. For example, a parsing function should define what it returns when parsing fails, rather than returning something that looks valid but is actually incomplete. When you design functions with testability in mind, you naturally design for edge cases and for clarity. This is why functions are not just a coding style preference. They are a safety tool. They make it more likely that your automation behaves predictably under strange conditions. Predictability is what allows teams to trust automation enough to rely on it. It is also worth understanding that functions can reduce risk by controlling side effects, meaning actions that change the outside world. Side effects include writing files, modifying configurations, starting services, or sending requests that cause changes. A function that mixes side effects with logic can be harder to reason about because calling it might do something irreversible while you are still trying to decide what to do. A safer approach is often to separate decision logic from side effects, such as having one function decide what action is appropriate and another perform the action. This separation makes it easier to review and to add guardrails, because you can validate the decision results before executing changes. It also supports safer iteration, because you can loop over decisions and verify them before applying them. Even if the exam does not ask you to write code, it may describe designs that either mix or separate concerns, and the safer option often reflects separation. When you separate logic from side effects, you reduce the chance that an unexpected path triggers a dangerous action. The biggest takeaway is that clear functions turn automation into a set of reliable building blocks rather than one giant, fragile chain. When you encapsulate logic, you limit scope, reduce repetition, enforce consistent error handling, and make behavior easier to reason about under pressure. Those qualities reduce operational risk because they prevent the kind of hidden interactions and drifting copies that cause surprises in production. On exam day, when you see questions about organizing automation logic, look for answers that create clear inputs and outputs, minimize hidden dependencies, and keep risky actions controlled. Those are function-friendly designs, even if the question does not use the word function explicitly. Over time, this approach makes your automation easier to extend because new features become new blocks rather than more tangled lines. That is how scripts grow into tools without becoming dangerous. Clear functions are not about fancy code. They are about building trust in automation, which is the real goal in operations.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit baremetalcyber.com.